All right, so here we're going to do a two-sample t-test for this one as well. We have this data here. All right, so the first thing we need to answer is, based off this information here, what are the null and alternative hypotheses, right? The null is that the means are the same, so mu1 equals mu2, and then they want us to test the claim that the longevity for archbishops is less than the mean for monarchs. All right, so that this is less than this. All right, so therefore that mu1 is less than mu2, so we're going to choose C for that. So now let's go enter our data, and I've already done so in the calculator over here, and we'll show you what we do here. You hit stat, edit, and so what you'll do in the list 1, go type in all the archbishop ages, or years, and you'll notice there's more archbishops than there are monarchs, and that's fine. They don't have to be the same length. Alright, so I've entered all the data there on both columns. We'll go over and do test, and we're going to do a two-sample t-test, and we're going to use our data this time. We have a list 1 is the one set of data, list 2 is the other. And again, our hypothesis test is that one is less than the other, so we do less than mu2. We leave pooled as no, and we go down to calculate, and so we get our test statistic and our p-value here. So let's enter those into our question now. Alright, so again, based off the calculator output, we put negative 1.90. We round to 2 decimal places, and the p-value is 0.033. Now the next thing they're going to ask is we need to test this now and write our conclusion. So based off the p-value and the significance level, again, it's important. This is a pretty low p-value, but that's not what we were testing against. What we're testing against is 0.01. Typically we test against 0.05, but this is all deciding how confident do we want to be, and so this number is not less than this, so we fail to reject. There is not sufficient evidence, right? Those two go hand in hand always. Right, so the next part wants us to calculate the confidence interval. So what we do is we go back into our calculator here, and we're going to do stat, and we go over to tests, and you go all the way down to option 0, two-sample t-interval. We're going to do an interval for this. Again, we're going to use our data that we've entered in, and now the confidence level is the only thing different. We're going to put a 0.98. All right, here's the reason we put 0.98, is that we, even though we did a one-tailed test over here, when we worked this problem, we were trying to prove that one was less than the other. When you do the normal curve, we're just trying to prove that this area right here is 1% or less. Right, that's what the 0.1 significance level means here. When you do an interval has to be balanced. All right, so what we do is we give another 1% on the other end to try to show the balance here, and so therefore that leaves, what that leaves here in the middle is 98%. Right, if we've got 1% on the top end, 1% on the bottom end, then 98% is what's in the middle. And therefore, that is why the confidence interval, the confidence level on the calculator should be a 0.98. So it's 98%. So you basically double the significance level, and the pool will still stay no, and we hit enter. And this is where we get our interval is negative 4.5953, and then the top end is 0.620 when written to 3 decimals. And so our final statement here that comes from this will say, does the confidence interval support the conclusion of the test? And the answer is yes, because the confidence interval contains 0. So in other words, the difference between the longevity of an archbishop and a monarch could possibly be 0. As you can see, I mean, as we got from our p-value, that's a really low p-value. It almost meets the standard that we need to be able to agree that archbishops do have less longevity than a monarch, but this edge right here goes just above 0 by 0.6. It's not far, but since it does contain 0, that means that it is possible that the difference between the average ages of monarchs and bishops could be 0. So therefore, it's possible that there is no difference between archbishops and monarchs.